This lesson will be on triangle definitions. Today your objectives are: I will be able to define three angles classified by angle measure, to be able to define three triangles classified by side length, and you'll be able to draw any of the defined triangles, or really just a rough sketch. We're going to start with the exercise in the front of the notes. They're going to give you a picture, or actually a box full of three triangles, and you have to make a statement that is true about all three triangles, not just one or two. Looking at this first box, we have the first triangle where you have two side lengths that are 1.21 and one side length 2.1. So you might say to yourself, well, these two side lengths are congruent. Let's see if that pattern continues throughout. If you look at the second triangle, however, you have three different side lengths, and the same with the third as well. So that pattern does not actually exist. However, if you look at the angles, of these three angles, one of them is larger than 90 or obtuse. If you look at the other two triangles, you will also notice that the other two triangles also have exactly one obtuse angle, this being 120 degrees approximately, and this one being approximately 136 degrees. Each triangle has one obtuse angle. So the statement we can make is all three triangles have one obtuse angle. And to remind you, an obtuse angle is an angle that's larger than 90 degrees, but also less than 180. The next box, we have three triangles again. So if we check the first one, the side lengths, we have two side lengths that are the same. Let's see if that pattern continues here. 1.5, 1.85, 2.19. This triangle has no side lengths that are congruent, so therefore that pattern will fall short again. If you look at the angles though, we have three angles all below 90 in this first one, so they're all acute angles, three of them. If that pattern continues, we could probably make a statement about that. Let's check to see the other two triangles have the same thing. 42 degrees approximately, 57 degrees, 81 degrees. All three of those angles are also less than 90. The third triangle, 61 degrees, 40 degrees approximately, and 79 degrees. All three of those are also below 90. So all three triangles have three acute angles. Remember that acute angles are angles that are less than 90 degrees, but larger than 0 degrees. So to recap, first box we had three triangles with one obtuse angle, and in this box we had three triangles with all three angles that were acute. This last box, if you were to check the side lengths again for congruency, you would find out in that first one none of the side lengths are actually congruent, and neither of these ones in the second triangle. In the third triangle, they actually have two that are congruent, but that pattern does not exist throughout. What does exist throughout is a 90-degree angle in each triangle. Every single triangle in this box has one right angle. So that is a statement that is true about all three. All three triangles have one right angle. Remember, a right angle is exactly 90 degrees. Go ahead and continue on to the back side of the sheet. In this first box, you're going to do the exact same thing again as the front. Make a statement that is true about all three triangles. The first triangle, we saw that we had the two side lengths that are congruent, as well as the two angles inside congruent. Let's see if that exists throughout all three. Two side angles congruent in this triangle. The answer is yes. We have 1.15 and 1.15, along with the two angles that are congruent. This last triangle, we have 4.97 and 4.97, so we have two side lengths congruent. So a statement here would be all three triangles have two sides that are congruent. This also means same length. So all three triangles have two sides that are congruent, or the same length. That is the pattern through all three. The next box, my copy is missing this middle triangle. We can work with these two here. If you look at the side lengths, we have 1, 2. Not only is my box missing the middle triangle, this triangle actually shouldn't be in this position. So go ahead and cross this one out from the examples. And let's focus on this triangle here. While this triangle does have a 90-degree angle, it is also important to point out that we have a triangle with three different side lengths, or no side lengths that are congruent. That is a type of triangle. So we're going to talk about a triangle later with three different side lengths. Or you can say no congruent side lengths whatsoever. In this last box, we have three triangles here. And in every triangle, if you look at the side lengths, all three side lengths are the same. All three side lengths are the same. All three side lengths are the same. Also the angles, 60, 60, 60, 60, 60, 60, and 60, 60, 60. All three triangles have three congruent sides and three congruent angles, which in every case it's 60 degrees. Now the two groups of three sets of triangles are grouped in a way to classify them by their angles and then by their side lengths. On the front, we are classifying the triangles based on their actual angles. You know, we had one set of triangles with one obtuse angle, one set of triangles with all three angles being acute, and then we had one set with all three triangles having a right angle. And on the back here we had one set that had two sides congruent, one set with no sides congruent, and then another set with three sides congruent. If you take your paper, flip to the next page, we have a space for definitions. And these definitions are going to be somewhat obvious based on the names of the actual triangle. For example, a right triangle, keyword being right, is a triangle with one 90-degree angle. Right triangle is a triangle with one 90-degree angle. And drawing it's pretty simple. Simply draw a right angle and then connect the two ends. And this triangle could be A, B, C. Triangle ABC is a right triangle. It is very important to put that box to designate that it is a right triangle. Otherwise, the sketch, people are not going to be able to tell that it is a 90-degree angle. An acute triangle is a triangle with three acute angles. Keyword being acute here. Acute, remember, means all angles that are less than 90 degrees. So, simply draw a triangle and make all the angles less than 90. So, for example, this could be 46, this could be 50 degrees, and this could be 84 degrees. All three angles would be less than 90 degrees. An obtuse angle, keyword being obtuse, a triangle with one obtuse angle. An obtuse angle being larger than 90, less than 180. So again, if you're sketching, you don't need to actually put the numbers in here, but go ahead and just make an obtuse angle, one that's very obviously larger than 90. This one being your obtuse angle here. So making sure that one angle is larger than 90, but less than 180. Now those three words we've probably heard, we definitely have heard before. Some of these next ones are going to be a little less obvious. You may have heard them before, but they're not as obvious as acute, right, or obtuse. The next one is equiangular triangle. An equiangular, equal angles, essentially what that means, is a triangle with three congruent angles. Triangle with three congruent angles. Since there is a certain parameter on triangles that the three angles must add up to 180, the equiangular triangle will always have angles of 60 degrees. So 60 degrees, 60 degrees, 60 degrees. Or if you want to just mark the angles without actually putting the measurements down, if you mark angles with a tick mark, like that, that'll show that the angles are congruent. Much like you would show tick marks on a side length, you can do the same thing with angles as well. Here, equilateral, same prefix, equa, it's going to be equal lengths. So equal lengths, think about that. This is a triangle with three congruent side lengths. So all three sides are actually congruent. And you can draw this using tick marks as well. If you put those tick marks there, you're telling the person looking at the sketch that these three side lengths are actually, in fact, the same length or congruent. The nice thing about triangles is that if your triangle is equilateral, it's automatically equiangular. If your triangle is equiangular, it's automatically equilateral. These two are equivalent statements. So if you call a triangle equiangular, automatically you can assume that it is equilateral and vice versa. So one will always be the other. Go ahead and turn the page over to the next side. Finish up these definitions. Next one's called an isosceles triangle. An isosceles triangle is a triangle with two sides congruent. So not all three, but just two. So when you think isosceles, you're going to think of two. Two sides congruent. This you can make by simply making two lengths that are the same and then the third one not be the same visually. And mark these two with one tick mark or two tick marks, just the same number of tick marks, and the third one will have a different set of tick marks, or none at all. Just make sure that the two side lengths with tick marks look similar in the sketch. Now, what's also unique about isosceles triangles is that the angles across from the two congruent side lengths, so this side length opening up to this angle here, is congruent to this side length. Sometimes they're called base angles here. And then this third angle here is like the odd man out, like this side length is. Lastly, a scalene triangle is a triangle with no congruent side lengths. So this is going to be a triangle. It could be right, it could be obtuse, doesn't matter, because it's classified by its lengths. Every side length is a different number of tick marks. That way you know that there are three side lengths that are not congruent. This is scalene. Sometimes they won't even be marked. it's an option to not mark anything, so that way people know that these three side lengths are not the same length. So the two objectives, the first two were classifying by side lengths and then by angles. The triangles classified by angles, they are right triangle, obtuse triangle, acute triangle, or equiangular. That's how you name them based on their angles. If you're naming it based on their side lengths, it is isosceles, scalene, and equilateral. These are your only choices for classification of side length, and these are your only choices for classification of angles. So if they ask you to classify them based on both or one or the other, you only have these names to choose from. In these examples down below, it says define the following triangles based on side length and or angle measure. Okay? Sometimes you only need to do one. In that one case would be an equilateral or equiangular triangle. In this case, if you're doing it by side length, are there any side lengths congruent in this picture? That's a question to ask yourself. And the answer is you have 1 tick mark, 2 tick marks, 3 tick marks. No side lengths with the same number of tick marks. This is going to be no side lengths congruent or scalene. That's classifying it by its side lengths. By its angle measure, we have one right angle here. That is a scalene right triangle or a right scalene triangle. The order doesn't really matter. So look at its side lengths and then its angles as well. 2, we have 1 tick mark, 2 tick marks, 3 tick marks. That's going to be another scalene triangle based on its side lengths, because there's no side lengths congruent. We have no angles marked here, but this angle looks like it's bigger than 90. If you flip it over this way and kind of make it horizontal, a 90-degree angle probably looks somewhere in there, and this would be clearly bigger than that angle. Okay? Let's make that a little darker there. That would be a 90-degree angle, and that's clearly past the 90. So this is going to be an obtuse triangle as well, because it is an angle that's larger than 90 or an obtuse angle. This third one, by its side lengths, you have 2 side lengths that are congruent, making it isosceles. Isosceles triangles have 2 side lengths that are congruent. Looking at its angles, this angle is definitely acute, less than 90. If you need to check the other one, simply just hold it up, make sure the side length is horizontal, and then kind of like either imagine a 90-degree angle or kind of draw it in, and you can clearly tell that it's less than that 90-degree angle there. So this one's going to have 3 acute angles, which makes it an acute triangle. So you just go by making it based on, or naming it based on its side lengths and its angles. If you want to pause the video right now, go ahead and fill in 4, 5, and 6, and we'll check our answers to see if it's done correctly. These are the answers for the 3 bottom triangles. This triangle is isosceles obtuse, 2 side lengths that are congruent, and it has 1 obtuse angle, hence the name. This one, number 5, it could be equiangular or equilateral based on its angles being the same or the side lengths being the same. You could write both, but once you say one, essentially you mean the other one as well. They're equivalent statements. The 6th problem here, right isosceles, you have the right angle, and then the 2 side lengths are the same, hence the isosceles part, and the right angle, right triangle. Flip your paper over. This last page asks you to create the following triangles. I'm going to hop around a little bit to different ones to show you situations where you can draw a triangle, and there's sometimes where you can't, and it's an impossibility. Okay. So for example, right scalene. If you're going to do this one, first draw your right angle. Everyone should be able to draw a right angle. And then make sure that these 2 side lengths aren't the same. So make this one a little bit longer than the other one, or make that one longer than the other one, and then connect the lines. Now you have 3 side lengths that you know aren't congruent. It also has a name here, triangle ABC. There's really no order to this. Unlike angles, triangles, you have 3 letters. The order won't matter if you're making it to sketch on your own. So we have a right scalene triangle. Three side lengths that aren't the same, and a right angle in the triangle. Let's go to some other ones here. I want to go to number 5. Right equilateral. An equilateral triangle, remember, is equivalent to an equiangular triangle. And an equiangular triangle has 3 angles of all 60 degrees. So when you have those, if they're all 60, there's no way that one of them can be a 90. Because once that turns into a 90-degree angle, it's no longer equiangular, which means it's no longer equilateral. This one is not possible. If it just said equilateral, wouldn't be a big deal. But as soon as you throw that right in there, it's impossible for a right triangle to have 3 side lengths that are the exact same. Let's go to number 6, obtuse scalene. Make an obtuse angle much larger than 90 and make sure the 3 side lengths are the same. So obtuse, scalene, 3 side lengths are the same. GHJ. You can name that however you want. Just make sure you name it. Should be capital letters. They're given here. Don't replace capital with lowercase because they do have different meanings in terms of geometry. And finally, number 9, scalene isosceles. This one is not possible because you have 2 different names based on their side lengths. Scalene has 3 different side lengths, while isosceles has 2 congruent side lengths. These 2 statements are contradictory. They can't happen at the same time. Therefore, this one is not possible. So sometimes you have to think about, well, is this actually possible? Can I make this triangle actually work? And majority of the time on the back here, you can. But in these 2 cases, 5 and 9, you actually cannot make it, and it's okay to put down not possible. So to recap, your objectives were to define triangles based on their side lengths. We did that. And to look at those names again, go to the page that ended with these 2 boxes here. Triangles classified by its angles. We talked about right, obtuse, acute, and equiangular. Triangles classified by its side length. Isosceles, scalene, equilateral. Remember that equiangular triangles are the same as equilateral triangles. So you don't need to name those both. You can name one or the other. Isosceles, 2 side lengths are the same. Scalene, no side lengths are the same. And equilateral, you have all 3 side lengths the same. We talked about how to identify them through sketch based on their tick marks. And lastly, we learned how to actually sketch them freehand by putting in correct icons or visual aids to help people know exactly what this right angle is. So putting the box in there helps. Putting the tick marks lets people know that the side lengths are different, or they're the same depending on the situation. Okay? And that's it.